Okay, class, today we're going to be doing investigating monomials. Now, when looking at monomials, there are different types of monomials. One thing a monomial can be, if you look at the chart to the left, is it can be a number. So we have 2, 5/3, negative 8.5. It also can be, as you see, we have a 2x, so it can also be a variable. Or it can be a product, meaning a multiplication of a number and a variable. So these are the different things that a monomial can be. Now let's look at what monomials are not. If you look at the first one, 2 plus x, it can't be separated by addition or subtraction. It also can't have a variable in the denominator, and it also cannot be under a radical. So these are the things that a monomial cannot be. So make sure you jot that down. Now, using the monomial above, identify examples of the following definitions. So what is a constant? A constant is a monomial with no variable. So above, what would those constants be? If you said these, you are correct. Now, what you also have in a monomial is also a coefficient. Now, a coefficient is the numeric value or the numeric factor of the variables. So here are the examples above that constitute a coefficient. Now remember, it's referring to the 2 and 2x, not the whole value, just the 2. It's also referring to the negative 8.5 in the monomial negative 8.5 xy squared. And then we have the degree of the monomial. Now keep in mind, it's going to be the power of the highest degrees combined. So 2 to the x is related to the first power, so the degree is 1. 5/3 to the y squared is to the second power, so that degree is 2. Whereas negative 8.5x is to the 1 and y is to the 2, so the combined total of that degree would be 3. So what do you think about the next one? Because I have 2 a's, 3 b's, and 7 c's, I really have a degree of 12. Because there's no variables on the square root of 5 or 0, I have no degrees there. Okay, let's go to the next page. So now we're going to look at how we simplify monomials. Now, in looking at multiplying, the easiest thing to do, guys, is to write it out. 5x squared means I have 2 x's. So I have 2 x's here. And 3 y's. So it's easy to just write them out. 4x to the y fourth means I have 1x, but I have 4 y's. And then using your numbers, you multiply and you just reorder it. So I know 5 times 4 is 20. And I know that if I look at the total number of x's, I have 3. So that's going to be x to the third. And if I look at the total number of y's I have 1, 2, 3, 4, 5, 6, 7. So that would be y to the 7. So that's what you should have gotten there. So take a moment and try to do the dividing one. Now what happens when I have 1 over 1 or 2 over 2? It reduces to 1, right? So the same thing's going to happen here. That's going to reduce to 1. That's going to reduce to 1. That's going to reduce to 1, or cancel each other out. And what am I going to be left with? I know that 18 divided by 6 is 3. And then I know that once I cancel out my x's, I'm left with 2 x's on top. Well, 3 x's on top. And I'm also left with 1 y on top. So what you should have gotten is that. So let's talk about the shortcuts for multiplying. So what I did in actuality is I multiplied my coefficients and I added my exponents. Whereas when it comes to dividing, I divided my coefficients, but I subtracted my exponents. So there is a rule for that. So if I have a to the m power times a to the n power, that's the same as a to the m plus n. Now note the basis, which is your whole number, must be the same. So if I didn't have both a's, I couldn't combine that. So what would be the rule on the other one? Correct. That would be am minus n. I would subtract. Now there's some other rules that we have out there that work as well. So let's look at a to the negative n. Remember that negative n means that it's under 1. So that a has to go to the bottom and it becomes a to the n power. Well, the same here. that 5 would have to go to the bottom, and it would be 1 over 5 squared. Let me try to write that again. It would be 1 over 5 squared and 5 squared would still give me 25. So what about x to the negative 4th? What would that be? Correct. That'd be 1 over x to the 4th. And what about b to the 3rd over b to the 9th? Think about how many are going to cancel each other out. I would just write that all out. 3 would cancel each other out, and I would be left with 6 on the bottom. So that's a rule as well. Another rule is when you have two exponents being separated by parentheses, you multiply. So 5 halves to the 2nd power would be 5 to the 6th. X fourths to the 5th power would be x to the 20. And b negative 2 to the 6th power would be b negative 12. And then the next rule just tells you that if I have a fraction that is in parentheses and it's squared to an exponent or raised to an exponent, it's going to apply to everything on the inside. So not will the 5 just be squared, but the 8 will as well, giving me 25 over 64. So this x will be to the 7th as well as my y. This b cubed will be to the 5th as well as my c squared. And then the last rule just says that if I have something in parentheses, the exponent outside parentheses applies to everything inside of the parentheses. So those are the general rules. Okay, so now we're going to work a sample problem or two. Okay, so on this first one here, if I have 2ab squared times negative 4a to the 3rd, b to the 3rd, c, what do I really have? And remember, if it's easier for you, you can write this all the way out. And I'm just going to write this first one out. So what I really have is 2a, try this again, I'm having a little trouble with the pen here. Okay, I have 2ab, and then I have negative 4, 3a's, 3b's, and a c. So because I have parentheses, that's telling me to multiply. So I would just multiply my 2 times 4, and I would get a negative 8. And then I would look at my b's and my a's. I have 4 a's. I have 5 b's, and I have 1 c. So that would be my answer there. So now I want you to go ahead and work 1 through 6, and we're going to pick up there in class. All right, good luck. See you tomorrow.